about is JavaScript design patterns. This is, as you can imagine, a very exciting subject, right? But even though the topic is a little boring, we will do some interesting things in terms of learning design patterns, specifically in JavaScript, and seeing how they compare to what we may know in the Java world. So before we get started, how many folks in here are Java developers? Okay, let me rephrase the question. How many folks in here are not Java developers? Oh, wow. Okay, that's a lot. I didn't expect that many. So what do other people program in? Let's take how many folks do web stuff, like HTML, etc.? Okay. What about Python? A couple of Python people. Ruby? Any Ruby people? Okay. What else? Anyone doing any Clojure, for example? Oh, wow, one person doing Clojure. Okay. You do that for real or for fun? For fun. Okay, that's okay. So we're going to kick off and talk about a few things. So at my company called Triplingo, we build foreign language tools for travelers, and pretty much everything that we built is either written in Ruby or JavaScript. Actually, 90% of our code base is in JavaScript. And I have a classic server-side Java background before I started this company. So I had to learn things the hard way in terms of learning JavaScript, learning all the different things around it, and trying to get my head around exactly how to write JavaScript in large scale. And what I've done is I've taken some of those lessons I've learned over the years and distilled them into this talk and the last talk of the day that I'm giving, which is on advanced JavaScript for Java developers. So what we'll do is we'll talk about design patterns, we'll go over code examples, but one warning I would like to issue is that even though you learn all these great patterns today and you see how we code them, you probably don't want to go out and start using them for everything, right? Because if you're like me, you have like a new shiny toy, or you learn some new programming language or something and you want to start using it right away. The idea here is not so much to use these patterns on a daily basis, but it's more to understand them and to see how they manifest in different frameworks that you may use today. Okay? So, speaking of frameworks, we have an overload of frameworks in the JavaScript community today, right? So you guys probably recognize some of the frameworks that are on the board right now. Backbone, Knockout, Angular, Batman.js, right? There's so many of these frameworks. But one thing that almost all these frameworks have in common is that they utilize a lot of the design patterns that I'm going to talk about here to create the features of that specific framework, right? So again, the idea for us is to learn the design patterns, see how they're applied in frameworks so that when we use a framework, we know what's going on underneath the hood. We understand when you use Backbone, for example, and you create a new model object, what is it actually doing? How is that functionality implemented? So if you don't know, when you do a backbone.model.extend, for example, what you're actually doing is you're invoking a factory pattern so that Backbone will provide a new model object for you in a very specific way, right? That's what a factory pattern does. Okay? Oops, wrong button. Let's try this again. All right. So with that, when we talk about frameworks, one of the reasons why there's so many frameworks in the JavaScript world, especially compared to the Java or the Ruby world, is that unfortunately JavaScript doesn't provide you with a lot of the mid and high-level constructs that are necessary in a programming language to be successful. So what people have done is they've created these frameworks to fill in the gaps of those different things that are missing. Right? And we'll talk about them specifically as we go through and look at some of the very basic patterns that we have. And we have to have these frameworks, and we have to have these patterns, and we have to have these best practices in the JavaScript world, because otherwise you end up doing a lot of copying and pasting, you end up writing a lot of boilerplate code. And again, the idea whenever you're building something is not to write a lot of code, right? Your goal is never, I'm going to write some code. Your goal should always be, I want to solve a business problem. I want to fix something, or I want to create a feature or something like that. It's not about writing the code per se. It's more about building something. And when you try to build something, you want to write as little code as possible, because the problem with writing a lot of code is that somebody has to maintain it, right? And usually that somebody is you, and that's part of the problem. So before we even get into some of the larger topics here, I will mention there are a few things that just out of the box when you use JavaScript, you probably need to have. And the top two on my list is always underscore and moment.js. Underscore is a utility library for working with collections and doing lots of other things, but it's very small, and it fills in some of the gaps that I was mentioning before in terms of the utility that the JavaScript platform itself provides. And moment.js is a library for working with dates. Right? And everyone's familiar with Jquery, so I won't talk about them. Again, I will extend another warning. Our goal here is to understand these design patterns, and we don't want to over-engineer the solutions we build, right? We build. That's the worst thing that you can possibly do, except do early optimization. All right, so let's talk about JavaScript patterns. We're not going to cover all these patterns. I'll pick some of the patterns which I think are particularly useful to know and learn and understand. But when we talk about creational patterns in JavaScript, we have several that you probably will recognize. Constructor, factory, abstract, prototype, singleton, and builder. Right? So how many people in here have ever used the singleton pattern in Java or Ruby or whatever? Okay, for everybody who didn't raise their hand, you need to wake up, because everyone in this room has used the singleton pattern. I guarantee you, if you've ever coded anything, if you use Spring Framework, for example, their whole implementation is based around singleton patterns. Right? All right. So the next one are structural patterns, such as decorator, facade, flyweight, adapter, and proxy. You may have used some of these. If you're in the Java world, you probably used a decorator. You may have used a facade, right? There are various different uses. But again, we'll look at some of these to try to get an idea of how they actually manifest in JavaScript. And then, of course, we have behavioral patterns, such as iterator, mediator, observer, and visitor. And pretty much everyone in here probably has used at least one of these, and that would be the iterator pattern. All right, so what we're going to do first is we're going to start off with the namespace pattern. Shockingly enough, JavaScript doesn't have namespacing capability in the language. How do you do namespaces in Java? Right, you use the package keyword. It's built into the language. It's super easy, right? Well, guess what? JavaScript doesn't have that. So what folks in the community have done is they've kind of coalesced around what's called the namespace pattern in JavaScript. And this isn't a real pattern. I call this more of an organizational pattern rather than a hardcore computer science design pattern. But let's have a quick look at what a namespace pattern does. All right? What I'm going to do is I'm going to drop to my code editor, and I'm going to walk through this code. Is that font large enough to read in the back? Yes? No? No? Okay. This is going to be interesting. Let's see if I can just do this. There we go. Wow. That's really big. Okay. All right, hopefully that's a little bit better. So what we do in the namespace pattern in JavaScript is basically we create a global variable, like what we have on the first line. What the first line does, it says, create a new variable, but if the variable already exists, don't nuke it. And what we do is we create this variable, we assign it to an empty object. That's what the double curly braces, the open-close curly brace is basically creating a new empty object. Right? And then once we have that, what we can do is we can start building up on that. So I have my base package name, if you will, called app, and then I can do app.services, right? And now I have a subpackage, if you will, under that. And later on what I can do is when I want to create a real service, I just do app.services.userService, right? So this is how people in the JavaScript world organized their code base at a very, very fundamental kind of base level, okay? Oh, and by the way, I forgot to mention, if you have any questions at any time during this session, please raise your hand or shout it out or whatever. Okay? Happy to take questions at any time. All right. So this is the namespace pattern, and you might be thinking, well, that's pretty simple. But again, what we're trying to do is we're trying to fill in the gaps that JavaScript does not provide for you. And it starts with very fundamental things like the namespace pattern, which is unfortunate, but it is what it is, and we have to deal with it as programmers. All right? And one thing to note is we're just using JavaScript object literals, right? That's the open-close curly brace just creates an object, i.e. specifically an object literal. And it is a single global object. All right? When I talk about this in a couple of minutes in more detail with the module pattern, you will understand why the single global object is important to know. All right? So the next pattern, again, this is an organizational pattern called the module pattern. So the module pattern essentially gives you encapsulation. Unfortunately, in JavaScript, it's difficult to do encapsulation. So let's jump back to our code editor here. And what we have here is I've created a new service or a new utility called utility. And it does two things. it implements is not string and is string. Actually, I haven't implemented it. This is just for demonstration purposes, but I could implement a quick bit of code to check if something is a string or not a string. But this is a basic module pattern. What we have is we have app.utility that's assigned to an immediately invoked function call, an IIFC, which goes and runs this code. But what we're doing is we're creating a new object that has two keys, is not string and is string. And with this, we have essentially created an API, a higher level API for doing stuff in our code. So if we wanted to run this, what we would do, let me just comment out some code here really quickly. I don't want this noise in here. Okay. So when we want to use this, what we would do is we would simply say app.utility.isNotString and isString. So if I go run this, you'll see the output at the bottom of the screen there. And obviously, I haven't really implemented it here. I just have these console.logs in here so that you can see what we're specifically calling. But you can see it works, right? It's fairly straightforward. And the way we're calling this is we're doing app.utility.isNotString and app.utility.isString. All right? Is everyone with me so far? Is anyone falling asleep yet? I know it's after lunch, like I said. But does this make sense to everybody? Yes? Okay, good. All right. So again, what we're aiming for is to build encapsulation. And if I go to the next slide, right, so I've already covered the basic pattern. The one that's most prevalent in the JavaScript world is actually what's called the revealing module pattern. And this looks slightly different. So I have an implementation of a revealing module pattern here. It's called app services user service. And at the top of it, or at the very beginning of it, you can see that I have this funny syntax here with the open parentheses and an anonymous function declaration. Okay? And if we go to the end of it, you can see here's the end of it. Here's the end of that anonymous function declaration, and I have an open close parentheses here. Okay? So what is this doing? This is essentially an implementation of what's called an IIFC, or immediately invoked function call. Right? Sometimes it's also called an IIFE, immediately invoked function execution. Okay? But what this does is this provides us scope safety and encapsulation. Because in JavaScript, there's only one way to create scope safety. Does anyone know what that is? Or there's only one way to create scope in JavaScript, a new scope. Does anyone know the only way in JavaScript to create a scope? You create a function, right? In the Java world and the Ruby world, there are lots of different ways to create scope, right? You can, even an if block has its own scope. But in JavaScript, there's only one way to create a scope by the developer, and that is by creating a function. Hence, that's why we have this funny syntax here at the top where we are essentially just creating an anonymous function and executing it so that we get encapsulated, i.e. scope safety. Okay? I talked more about this in more detail in the last session of the day on advanced JavaScript for Java developers. But let's get back to our revealing module pattern here. So I have a bunch of different things in here. I have a login function. You can see I've just kind of mocked this out for now. But I have login function. I have this thing called logout internal, get username, etc. And again, in my return statement, what I do is I create a new object literal with these keys of login, logout, get username, and uname. Okay? And what these do, if you look at the syntax highlighting, you'll see how they point back. So for example, logout is the key that's exposed to the outside world in this object. And the actual thing that it points to is this other function called logout internal. Okay? And this is what a revealing module pattern does. It allows you to specifically reveal things inside of this function execution to the outside world. It's like creating a course-level API in JavaScript. Okay? Again, it's course-level API, not fine-level, but a course-level API. It's a module level, not a class-level type of thing, if that makes any sense. All right, so what we do, let me comment this code out so we get rid of some noise. So I have my user service, and when I want to use it, it's pretty straightforward. What I do is I say app.services.userservice login. And you can see from the syntax highlighting where it points to. And in this case, what this is doing is just doing a console.log, logging in user, and it's also assigning that passed-in user parameter to an internal variable called username. So we are allowed to keep state inside of this module. All right, so if we go run this, let's see what else we're calling. So we also call app.services.userservice.getUsername, and then we console.log appServicesUserService.uname. So if we double-click on those, highlight them, you'll see that One points to this thing right here, uname, and getUsername points to this function called getUsername. So when I run this, what should my output be for these two console.logs? I should get the logged in user is, let me change this back to my name. Okay? So I'm going to log in the user that's going to set the username. What should I get as output from these two console.logs? What should I get as output? I should get the logged in user is Pratik, right? What if I were to tell you if I ran that, that's not going to happen? What would you think? Anyone want to bet 100 rupees that this will break or not break? Anyone want to take any bets? All right, so that's interesting. We saw that the login ran because in my code up here, I say logging in user, right, when I invoke login. So that's right here. And then the next one is the logged in user. It printed out the name as we expected. But the last one said the logged in user is hello. So what's going on here? Why would this be broken? So let's go back and look at our code real quick. Let's study this a little bit. All right, so I have app.services.userService. It's assigned to an IIFC. And I say var username equals hello. It could be anything, right? I could initialize this to an empty variable. And I'll go run this again. And you can see now it's empty. Or I could say empty, go run it again. And now you can see it just says that random word that I have in there. Okay? So what's going on here is that because we're using an IIFC, immediately invoked function call, again, that's the thing at the top of this right here. What's happening is that this is a function that gets invoked immediately inline as you go from top to bottom. Okay, you can see there's the top of the function, anonymous function declaration, and here's the end of the anonymous function declaration with an open close parens. That means execute that function. So what happens is, we're executing this function from top to bottom, just like you would in any other JavaScript file. And when we do this part right here, we have created a new object literal, and this uname variable gets assigned a username, which when we hit this point in code, as we're going from top to bottom, is set to hello. Right? So that's what gets assigned to that. So you might be thinking, well, how does getUsername work? Well, what getUsername is doing is that it's invoking a function that's inside of that other function, anonymous function that we have. So what happens in this case is when we call getUsername, it goes up here, grabs this username at that point in time. What we've done is we run this login after we've created that user service. So the state is initially blank, and then we call userService.login. That login points to here. That login comes up to here. Here's our user parameter. That gets assigned here. And you can see we're doing the assignment at that point in time. Okay? So this is the way, this is a caveat that you have to be aware when you're using a revealing module pattern or any module pattern, that you have to be careful that you don't initialize something and expect that initializers or that initialized value to still be there depending on the state of that object. All right? So let's have a look at one more really quickly. The next one we want to look at is what's called the import Mixin module pattern. All right? And I have the code for that right here. And this is slightly different. So what I'm going to do is I'm just going to define a service called event service at the top here. Right? And there's only going to be one thing in it. It's going to be called add event. Let's just double check this works. I'm just going to comment this out. And I'm going to do, all right, here's my event service. I just alias that into my namespace in this case. So you don't necessarily have to define stuff with the namespace initially. You can alias something, i.e. do a assignment to event service. So I could do something like this. And we're currently at GIDS 2014. And I'm going to go run this code. And you can see that it ran. The event service ran. You've added an event called GIDS 2014. All right, no big deal. Okay? In terms of our module pattern, let's say that instead of directly reaching out and calling this event service in our user service, so let's say when somebody logs in, we also want to invoke the event service to add an event. Right? So what I could do is I could take this app.services.eventService like so, and I could do add event, and let's just call it keynote. Well, let's call it something else. Let's call it JS patterns or something. Okay? Let me resize this screen a little bit. All right. So let's go down now and invoke the login function, and let's see what happens. Let's make sure this works. So again, what I'm doing is I'm directly referencing by its namespace, and I'll highlight it for you. You can see the event service is right there. I'm just directly invoking it, right? So this is one way you could use it. You can see I ran it. It said you've added an event called JS Patterns instead of GITS 2014. So let's take this out, and let's implement this in a slightly different way. If we then look at this again, this immediately invoked function call that we had, in the last example, I didn't pass in a parameter, but you can pass in a parameter. It's just another function invocation. So I have my immediately invoked function call. It's expecting a single parameter. In this case, it's called EV service. And if we go to the end of that, you can see that when I do the invocation, I'm actually passing in that event service, which is passed in here as the parameter during the execution, right? It gets mapped to this EV service here, and then I can go invoke it. So when I go run this, this should now say keynote, and you can see indeed it does, right? So this is what's called an import mixin module pattern. Now, if you look at this, does this remind you of something that you probably have done before in Java? Anybody? Does this remind you of something that you have done in Java? A utility that you may use. It has two initials. DI. Dependency injection, right? So this is essentially a way that you can do dependency injection in JavaScript. But in JavaScript, it's not necessarily called, it's still dependency injection, but the specific pattern that we're using here is what's called an import mixin module pattern, okay? So if you use the Spring framework, you're familiar with dependency injection or your newer versions of JEE. And actually the Spring Source folks actually have a library called Cujo.js that allows, it's a dependency injection framework for JavaScript. But you don't really need to use something heavy like that. You can just code it up yourself. It's very straightforward, as you've just seen. Okay? So let's move on and talk about PubSub. Again, what I'm trying to do here is I'm trying to show you the patterns which I think matter the most when you're working in JavaScript. And they're the ones that are important. So the PubSub pattern is something you are probably familiar with. It's the classic publish-subscribe type pattern. The way we specifically use it in JavaScript is for dynamic updating of UI elements, data synchronization, lots of things like that, right? And essentially what a PubSub is compared to an observer pattern is that what it does is it separates the observer and the sender using a channel, right? So it's very similar to JMS, right? Java Messaging Service that you've probably worked with in Java. But the one key difference between the way we think about PubSub in JavaScript is that it is not distributed or networked. The PubSub in JavaScript is a in-process publish-subscribe mechanism. What I mean by in-process is that it's running inside of the web page and only there. You can't send a message from this web browser page to this other web browser page because those are in two different processes. When you do JMS, JMS is a distributed or network-based publish-subscribe mechanism. This is a process-based publish-subscribe mechanism. All right? So if you use Angular or if you use Backbone or any library, virtually every framework uses the publish-subscribe pattern. It is essential in JavaScript to use PubSub to be able to create a proper framework with it. For example, if you use Backbone, when you do win.app.todos.trigger, you're essentially firing an event using the built-in PubSub mechanism inside of Backbone. When you do a window.app.todos.on, for example, what you're doing is you're subscribing to events that will be broadcast over that specific channel. In this case, the channel is that to-dos object, okay, or to-dos collection. And actually, you don't even have to use Backbone or Angular to be able to use the PubSub pattern in JavaScript. If you're using Jquery, one of the little-known features of Jquery is that it actually is in the Jquery library already. They have trigger and on as something that's available, and what they do, the channel that they affix those publish-subscribe mechanism utilities on are basically around elements that are on the DOM. Okay? So I want to mention the observer because I think for completeness we need to understand this. The observer pattern is similar to pub/sub, but specifically in an observer pattern, there's tight coupling between the observer and a sender. Whereas when we use a pub/sub, it uses a third pattern in the middle called a mediator to essentially give us event channeling. Okay? So if you've ever written a observer pattern in Java or Ruby or whatever, that's the key difference between an observer and a pub/sub, is that there's a mediator which allows you to have loose coupling. And you want to have loose coupling so that you don't have tight coupling between different objects. All right. So the next pattern I want to talk about is the command pattern. Some of you may have written this, especially if you've written any command line utilities in Java. A command pattern essentially allows you to do delegation of a function or method invocation. It's exactly like the classic command pattern in Java. So what does a command pattern allow you to do? It allows you to do two main things. It allows you to do indirection and allows you to do invocation chaining. And we'll see what that means in just a second in some code. All right? So let's drop down to our editor and let's have a look at a command pattern implementation. So what we're going to do is, and you can see I'm using underscore here, right? And that's the library I mentioned earlier, which is has lots of great stuff in it. So I have a car manager here, and it has a bunch of things a bunch of functions that it invokes: request info, buy vehicle, arrange viewing, audit sale, whatever. Right? It's got a bunch of stuff in it. So let's go make sure this works first of all. All right, let me just go comment out the other. Okay, good. So we have our car manager. Again, request info, buy vehicle, arrange viewing, audit sale, etc. So if I wanted to use the car manager to buy vehicle, I could say car manager dot buy vehicle, buy a Prius with this identifier. Okay? So I'll go run this, and that's not supposed to pop up. But you can see that you've successfully purchased item ZX123, a Prius. Right? So if we go look at buy vehicle, you can see all it's doing is it's returning a string with the parameters that are passed in. Right? So that's pretty straightforward. All I've done here is a direct function invocation against this car manager object. Right? So now what I could do is let's build up on this a little bit. So another way that you could invoke a function in JavaScript is all you need to do is get a reference to it somehow. So we did a direct invocation on this line right here. Right? We just said car manager dot. We used the dot syntax to do this. Another way that we can do this, in JavaScript, you can access any property of an object, whether it's a string or whether it's a function, by using the square brackets and giving it the string name of that specific thing that you want from inside the object. So here I have car manager, square brackets, go find me this thing inside of car manager called buy vehicle. Right? Here is buy vehicle. And then you can see I have an open close parens. So now we've upgraded from a Prius to a Volt. Right? So if I go run this, you'll see that indeed I have purchased a Volt with item number 1235. All right? So that's another way that you can do function invocation in JavaScript. So yet another way is you can use the apply function. And what the apply function does is once you have a reference to a function, you can do that function dot apply with these parameters. Right? So if we go look at the rest of the parameters with this, it says car manager, buy vehicle. So all this does is it reaches into the object, gives us the buy vehicle functions that is inside of it. And then we call dot apply. Again, that's the keyword in JavaScript to invoke something. And we have a couple parameters here. The first one for the apply function is you give it the context, i.e. the this that you wish to set. All right? And then you give it an array that contains the parameters that should be bound when that function is invoked. So now we've gone from a Prius to a Volt to a leaf. And if I go run this, you'll see that this works. I bought a leaf with item number whatever. Okay? So all I've done in these three examples is I've invoked the same buy vehicle function in three different ways. Direct invocation using dot notation, a sort of indirect invocation by going and grabbing it out of the object and then using apply. All right, so now we're ready to go and actually work and build up a command pattern. All right, so what we're going to do is a couple of things. Our command pattern name is going to be called execute. So inside of car manager, I'm going to create a new function called execute. So I have car manager.execute equals this function, right? It's going to take a single named parameter called name. And if you remember from our previous example that we just ran, what I'm going to do is I'm going to take the car manager, I'm going to go find that named function, and then I'm going to invoke it with apply. Right? Pretty straightforward. We just ran through that. This is the context I'm going to run it in, and in this case, I'm using underscore to say, give me all of the arguments except for the first one, i.e., give me the rest of the arguments after the first argument. Right? So let's go run this. Let's make sure this works. All right, so we have car manager.execute, right? And again, execute is our command pattern implementation here. Car manager.execute by vehicle, and here are the parameters. So now we're getting somewhere. We've gone from buying a Prius to buying a Tesla. Does everyone know what a Tesla is? It's the fancy electric car that they have in the U.S. All right. Go Google it later. It's a very expensive car, but it's all electric. All right, so anyways, car manager.execute by vehicle, and these are the parameters that I want you to execute it with. So let me go run that, and of course that does nothing because I haven't logged anything out. So what this is doing is it's going and invoking it, it's assigning the result of that to this result variable, and then I do return the result. And so now if I go invoke it, you can see it says, you have successfully purchased item blah, a Tesla. Right? So this is a basic implementation of a command pattern. There are a couple of other things I could have done in here in terms of going and grabbing this. So I did car manager name apply, and instead of using underscore to go and get the rest of the parameters, I could have called the arrays slice operator and tell it to slice off the first thing in the arguments array that's passed in. Okay? If you want to see what the arguments array looks like, we can do this. So when you invoke JavaScript, there is a built-in keyword called arguments inside of a function invocation, which is an object that contains all of the arguments that were passed to it. Okay? So by default, JavaScript is variadic. Right? They introduced variadics in Java 5, but JavaScript has always been variadic. Okay? That's the arguments object, and that's what we're doing here is we're basically just taking the name off so we have the rest of the parameters that we can pass to the underlying function invocation. Right? But now that we have this indirection in place, we're able to do a couple different things. What we can do, first of all, is let's say that anytime I invoke something in car manager using my command pattern, I want to invoke another function called debug logger. And what that debug logger does is it just prints out, you have called this function. Right? So now if I go run this, let me get rid of this console.log. Now if I go run this, it'll say, it helps if you actually have something that runs. Okay, so you can see that when I hit car manager.execute by vehicle on this line, it called up into here. It first called debug logger, which all it does is prints out you've called this function, right? And we just print out the function name, and then we actually go run the underlying by vehicle function, and you can see this is the output. You've called this function. That's from our debug logger. Then we actually run the thing and print it out. Okay? So we have this debug logger here. Now I can actually take this a step further. I have this indirection in place, so I can do a couple other things. I can come down here, and in my result, I can say, all right, so I've run the car manager.byVehicle, or whatever function in this case my command pattern is executing. And I can say, you know, with the results that I get from actually calling that byVehicle function, let's annotate the results in some way. And you can see I have an annotate results function up here. And all it's doing is it's just concatenating and creating a new string. It takes the thing that's passed in and just creates a new string and returns it. So now if I go run this, what are we going to get? We're going to get, you've called this function called byVehicle, and instead of just getting, you have successfully purchased, you know, whatever, what we get is from the annotate results, we get this annotate results, here are your results, right? I'm just doing some simple string concatenation to show you how the program flow is happening. Okay? So we pretty much done indirection chaining, invocation chaining, and some indirection here. But when you look at this, what does this remind you from the Java world? or from other programming languages? It's a 3-letter acronym to help you out. Anybody? Nope? Okay. Does this remind you of for advice or an around advice? Right? This is essentially the same thing. So this is a way that you can do aspect-oriented programming in JavaScript by implementing a command pattern. All right. So we'll talk about this a little bit more in a few minutes. But the basic idea with the command pattern is we get indirection and invocation chaining. Very important. So the next pattern we want to talk about is the facade. This is the same as the classic facade. It presents a facade to something that's usually more complex underneath. Well, we've actually kind of already implemented this. If you remember from our example of the user service that we created, i.e. the module pattern, what we did was we presented an interface to something that was more complex underneath as something different to the outside world. And this is the example of that. Right? So that logout that I had in my user service actually pointed to something else over here and was a facade for an underlying object. Okay? All right, so let's go to the next one, and let's talk about the factory. So the factory pattern in JavaScript is basically the same concept as the factory pattern in any other programming language. Specifically, the factory pattern is used for creating objects in a specific way. Most of the JavaScript frameworks that are out there use the factory pattern used in their framework. What does that look like? That looks like something like this. You have backbone.model.extend, right? And what that backbone.model.extend is doing is it's actually a factory pattern that reaches into Backbone and creates a model object for you in a very specific way, i.e. it is a factory pattern. All right? All right, so the next one we want to talk about is the Mixin. This is one of the most powerful patterns that we have in JavaScript. It allows you to do an augmentation or extends type of behavior. Okay? So when we look at this, what does a Mixin pattern look like in JS? Right, so let's say we have something called myMixins. It has 3 different functions inside of it. Move up, move down, and stop. All right? And then we have a car animator, which has a move left function. So what we can do is we can have our car animator, and let's comment this code out for the time being. We have a car animator. I'm going to new up one of these car animators, and I'm going to invoke move left on it. And when I call it, you can see it indeed, the car moves left. Now, my car animator, unfortunately, does not have a stop function. So if I were going to run this, it'll move left, and then I'll get an error saying, I don't know what this stop thing is. Right? I haven't defined a stop function inside of my car animator. But fortunately, I have a stop in this myMixins object. So what I want to do is I want to mix in the myMixins object into my car animator. And there are several ways that we can do that. So the first way is I can use _extend function to say, in the car animator, mix in the myMixins. So now when I run this, what it will do is it will essentially merge this entire myMixins implementation into this car animator. So now when I run this, you'll see that instead of failing, I get a move left, and then it says myMixin stop, and it's printed some other crap out. Right? I don't know why it says this.myname. But you get the idea of what's going on here. Right? We've extended the behavior in a specific way. All right. So and the move left will still work. And one of the nice things about mixins in JavaScript is that you can have multiple mixins if you want. What does that mean? So I showed you the myMixins, and then I have this other mixin, which has a bunch of properties. It could be functions or just properties. But I also have so I have a mixin. This other mixin object that I have has a fly function inside of it. So what I can do here, actually, is let's get rid of this for now, and let's say to the car animator, my animator, first mix in, other mix in, and then mix in my mix in on top of that. So we're going to mix in these 2 other objects into the car animator so that my car can fly. All right, so if I go run this now, again, here's fly. The only place it exists is in this other mix-in. It doesn't exist in my mix-ins or in the car animator. But when I run this, you'll see that it's not going to work now. Okay, let's try that. All right, so you can see I invoked myAnimator.fly, and indeed it found that fly function that was in this other Mixin object. And again, what I did is I did basic object augmentation using the Mixin pattern, in implementation of which is underscores extend operator. Okay? All right, so let's talk about a few more patterns quickly. We've already seen that. I'm not going to spend any time talking about the prototype pattern right now. I talk more about this later. But another way that you can do essentially object extension is by using the prototype pattern. Specifically, this is an implementation of what's called parasitic inheritance, which is a way to work with prototypes in JavaScript, right? But I'm not going to talk about this in detail now. It's something I cover in the session later today, all right? So I do want to mention the decorator. The decorator is another way that you can do subclassing, right? If you think of it logically, what a decorator does. It allows you to add behavior to an existing class or an object. Unfortunately, doing a classic decorator implementation in JavaScript is very onerous, and it's complex. So I'm not really going to talk about it because we have other ways to do the same kind of thing, the mix-in or the prototype. All right? Finally, what I want to talk about is the MVC patterns in JavaScript. I think this is very important. When we talk about classic MVC, right, everyone has probably seen this diagram 100 times before. This is essentially a MVC if you're using Spring Web, if you're using Grails, if you're using struts. Is anyone still using struts, by the way? No? Okay, good. Oh, a few unlucky people. Okay. It's 2014. 2000 called and they want their framework back. Anyway, sorry. Had to pick on the struts people. So anyways, all these frameworks that I mentioned, struts, Spring Web, Grails, whatever, they all implement MVC. But the key difference between when we talk about MVC in JavaScript and those Java-based patterns is that Spring Web, struts, Grails are all, even Ruby on Rails, or if you use Django with Python, those are all server-side MVC patterns. Okay? The key there is that they're server-side patterns. Right? So if we look at this, everyone has seen this diagram 100 times. You understand what the roles of the model, view, and controller are. But when we talk about JavaScript, we have different patterns. We have MVVM, which stands for model, view, view model. And the way this works is that if you look at this diagram, you'll see we have a view. The view is decoupled from the view model, and we still have a semblance of a model object, but the way that they interact with each other is different. One of the key things is that we're sending notifications, right? So if you look at the text right in the middle, it says sends notifications, right? This part right here. Let's go down, right? So you can see right here we're sending notifications. Let me actually get my mouse up here. Right, so you can see we send a notification here, and also down here between the model and the view model, when new model objects emerge, we send notifications to the view model, which sends a notification to the view to tell it to go update itself. Okay? So this is MVVM. But the key here is that we're sending notifications rather than doing direct function or method invocation. So if we go back, you can see that pretty much there's not really any notification architecture in here. Right, in classic MVC. But in MVVM, we have something slightly different. Then we can also look, I don't want to talk about these in detail right now, or that specific slide in detail, but if we look at MVP, right, MVP is essentially what Angular implements, for example. MVP stands for Model View Presenter, okay? So we still have a concept of a model, but instead of having a view model or a controller, we have this thing called a presenter, right? And that updates things from the view. And when events in the view happen, it passes calls down to the presenter, and you can kind of see how this flows. All right? But again, the key difference between what we talked about with the MVC, MVVM, and MVP is that these two are client-side model view controller type of patterns. The key there again is it's client-side. So if you're as old as I am, you used to do work in the Windows world, right, using Windows Forms. And if you actually go back and look at the literature that they had, in the past we haven't had logic. When we do something with Spring Web or with Grails, we typically do a lot of the processing for constructing the view on the server. Today what we do with these frameworks like Backbone and Angular and Knockout and other things like that is we've moved all that logic from down here in the server up to the client, i.e. we're back almost to the client-server model where we have a thick client. With that thick client is written in JavaScript as opposed to, if you do Swing, Java Swing, right? Or if you do Windows Form or Visual Basic or Power Builder, all those other things, we've kind of gone back to more of a client-server model. So that's why we have these different patterns. And they manifest themselves differently because we're moving logic and we're doing actual processing on the client as opposed to doing them on the server. Okay? So a couple of quick things I want to mention in closing is everything that I've talked about in this session and more is available in this great book called JavaScript Design Patterns. But you don't actually have to go buy this book. The full contents for this book, aside from the pretty pictures and diagrams, are available on the author's GitHub account. So you can just go to GitHub, find Adi Osmani's GitHub account, and he has the entire text for this book online. Okay? So what I want to do in the last few minutes is just show how these things manifest in Backbone. We've already seen this in a lot of ways. I don't want to talk about Backbone specifically, but you guys are probably familiar with it. It's a minimal framework. You bring your own view, right, et cetera, et cetera. But if we go look at a few things inside of Backbone, you'll see that we have the factory pattern, right? We have backbone.model.extend. Right? That's using a factory. And one thing that I want to note here is if when we look at the way that you work with models in Backbone, right, what do? You do var item equals new item, after you've created it using the factory pattern. And then instead of just doing item.name equals pencil or item.color equals yellow, what you do is you have to do item.set name pencil, color blue. And then you can call item.save. So there are several things going on here in Backbone. And again, every framework does this to a certain extent. What's happening here is that you have to call item.set because that .set is actually an implementation of a command pattern. Okay? Set is the command that you're invoking, but when it calls down into the Backbone model object, that set actually goes and sets the property, obviously, but it specifically triggers a change event that gets propagated through the Backbone system so that you can listen to see that something has been changed in the model and go update a user interface. Okay? Similarly, when you call item.save, it triggers a synchronization event. It fires an event through the system that says, hey, an item object has just been asked to be saved. As a programmer, you can hook into that, and then you can go do something with it. You can save it back to the database or whatever it may be. So the .set in this case, again, is like a command pattern, but also underneath it is we have the publish-subscribe mechanism. Right? So when I call item.save, we're broadcasting an event over the built-in Backbone pub-sub mechanism to have it go do something. All right? So let's go through. Actually, I'm going to skip over these slides and talk about a few other things really quickly. Right? So if we go look at, if we actually go and look at how these apps work, or how you're supposed to build these apps, if you actually go look at the reference app, you'll see that, like you can see on the first line there, they're essentially using the namespace pattern. So when you actually go look at these examples, you can find a lot of utility in terms of how people construct these JavaScript applications and what patterns they're using underneath the hood. Okay? So with that, we are at the end of this session. I think we have about 5 minutes for questions. Is that about right? I don't know where the person has gone, but so what questions can I answer for you guys before we break up? Any questions? I can't see. No, did that all make sense, or are you totally confused? Totally asleep? So I do recommend going and having a quick skim through this book. This book is very dense, unfortunately. Let me go pull it up right here. The book is very dense. but it is actually a great book because he has a lot of stuff in here, and he actually walks through all the code that that you would have to write to go and implement these specific design patterns. All right. So if there's no questions, I thank you for coming. I hope you enjoy the rest of the conference.